Throughout the semester, we're going to use sets and intervals to record our answers to given problems. So starting with the definition of a set, it's simply a collection of objects. And here I have an example of two, the set A and the set B. A is the set of numbers -4, 0.5, 2, and 5. So when you're just talking about a couple of numbers in a list, you separate them with commas and put these curly brackets on the end. In example 1, I would like to graph this set on a number line. So I'm going to put A over here. Maybe on my number line I'll put a couple of arrows and then mark, let's see, maybe this is 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. So the set A contains -4. I'll put a circle at -4. 0.5, that'll be right here, halfway in between 0 and 1. We also get 2 and 5. So those red dots are in the set A, and it's only those points. Likewise, we have this other set B. So again, I'll start by drawing some arrows on the end, and notice that, okay, here we're starting at 2 and the numbers are increasing. So to get a good idea of what this looks like, you can really start anywhere, but maybe I'll put 0 over here, and then we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. And I'll mark 2, 4, 6, 8, and technically 10 is in there too, so I'll put that value down. And that's the best I can do with the number line that I've drawn. So technically there's infinitely many objects, but on this number line, I've listed just a few. Another standard notation we're going to use is interval notation. So this is not just when we have like a finite list of points, but when we have infinitely many points between two given values. So I have the definition of an interval written up here, but I think it's better to explain it just by using a couple of examples. So for example 2, here we have something called the interval from -1 to 2. The two numbers tell you where you first start and stop. So what I'm going to do is on my number line, I'm going to mark down -1, 0, 1, and 2. And this interval means I'm starting at -1, I'm ending at +2, I'm including both of those points, as well as everything that's in between those two numbers. So with this notation, if you see a bracket like this or like this, it means include. So you're actually including the two endpoints. Whereas if you see a parenthesis, it means you're excluding it. So let's check out this interval from 0 to 3. So we'll go to my number line. Let's see, maybe I'll start, okay, here's 0, 1, 2, and 3. This time, I'm starting at 0, I'm ending at 3, I'm including 3, but I'm not including 0. So I'm going to represent that with an open circle. So if we have a parenthesis, it means that we can go really close to 0, we just don't include the number itself. So again, just to point that out, if you have some type of parenthesis like this or like this, it means we don't include. And the last real possibility that we could have is for our interval, maybe it goes down to something like -infinity or up to +infinity. So for this one here, anytime you're dealing with infinity, technically that's not a real number, so it will always have a parenthesis associated with it. If I want to represent this interval on a number line, so what I'm going to do is mark maybe 4 is over here. And then you'd have 3, 2, 1, 0, -1, -2, and so on. I'm going to put a closed circle at 4, and I'm going towards -infinity, and I in fact never stop. So this interval means we're at 4, we're including it, and we're going in this direction. And for example 3, I again want to look at a set of objects. So we have like this curly bracket and a curly bracket with some stuff in between. So this is definitely a set. But this time, it's not just numbers. In fact, it's points. So those are things of the form x, comma, y, which we'd call a point. The first coordinate represents what's on the x-axis, and the second represents what's on the y-axis. So I just want to go through what it would mean to plot these points that are within this given set. Let's start with 1, 2. What this means is x is equal to 1 and y is equal to 2. To plot this point, a standard way to go about it would be to start at 0, 0, which is right at the origin. We go over 1 in the x direction, and we go up 2 in the y direction. And I'll put a circle here that this is the point 1, 2. You can also reason this backwards. If you're looking at this location, if you want to know the x coordinate, you can look down to the x-axis and see that it's 1. And if you want to know the y-coordinate, you can look over to the y-axis and see that, well, it's 2 because you went up 2 places. So either way you do it, you can either start at this point and go over 1 up 2, or you could think about, well, where's the location that gives me 1 on the x-axis and 2 on the y-axis? Anyways, continuing with this, let's look at the point 0, 5. Again, x is 0 and y is 5. What this means is, if we start at 0, 0, since x is 0, it means we're not going left or right, we're stuck right here, but then we go up 5 places to this location here. So that's the point 0, 5. Let's see what else we have. Negative 3, 1. Okay, what this means is, if we start at 0, 0, we're going to go 3 places to the left and up 1. This is the location of negative 3, 1. Okay, we also have the point negative 4, negative 3. Okay, this means starting at 0, 0, I go 4 places to the left, and now I go down 3 places here. So that's negative 4, negative 3. And then the last one, 4, 0. So I'll jot that down. This means I'm starting at 0, 0. I'm going 4 places to the right. Since y is 0, I'm not going up or down. In fact, I'm right at this location. And I have 4, 0 is located here. So that's it for this example, but I'll just reiterate that there's 2 ways to think about your points. Again, focusing on this one, 1, 2. Either start at 0, 0, go over 1 up 2, or if this is your location, to find the x coordinate, you can look down to the x-axis to see the 1, and look over to the y-axis to see the 2.